If you want to quickly and easily build an electric circuit model and interactively play with the elements, this is the place to go. For example, you can change the phase angles of the power sources in real time and watch the resulting changes in the power flow across the grid. There is no better tool to get hands-on expertise in electric circuits. You can access the browser-based tool via link below www.ecsp.ch. Let's start with a new circuit. Let's start with a voltage source, drag and drop. Double click in order to input the data. Then we add an inductivity. Double click on the right mouse to turn the element. Then we add a resistance and a capacitor. We connect the elements by means of connecting lines. We input the data of all elements. Double click, then you get access to the input mask. We click on the traces we want to see after the simulation. Then we run. One of the key features is that you can change the values of the element in real time. So in this case, for example, we have the transient voltage. When we start the calculation, we increase the capacitor. Then you can switch to continuous mode. In the continuous mode, you can see the effect of changing the resistance on the phasor angles of the elements. You can perform a frequency analysis. You input the lowest and the highest frequency you want to see. So this is then the result of this frequency analysis. You see the individual values of the individual traces as well as the phase angles. You can also run a phasor calculation. You have to input at what frequency you want to have the calculation executed. So this is the phase angle representation. You can also gradually go to more complex circuits. So in this case, for example, we add a transmission line to the circuit. We connect it. We can shift around groups of elements very easily. So we reconnect the group to the end of the transmission line. So this is a single phase transmission line. There are also 3-phase transmission lines available. Now we input the length of the transmission line, the impedance of the transmission line, the resistance of the transmission line. So this would be the length in meters. And we have also the speed in percentage of the light speed. In this case we put in 30%, I guess. This would be a typical high voltage cable. So we would have a 30-kilometer high voltage cable. Let's go to the transient time-based mode now and see how this behaves. So you can see the transient mode, and we can also change the elements again, and you see how this setup behaves. I can go for a longer simulation time. So instead of having only 20 milliseconds, I go for 40 milliseconds. The green curve stands for it's the current, the blue curve is the voltages, the red one is the power. Instead of having an RC circuit at the end, I just go for a R circuit at the end to close the line with a resistance. I put the high resistance value to start with. Then I want to see the voltage. So you see here the transient behavior just after switching on the line. And you can see how you can interactively change the elements. This is one of the key features of this program. So you learn a lot, especially if you're a student or if you are a teacher at the university, for example. You can easily teach electric technology or electrical engineering with such a tool. This is now frequency behavior of this setup. So this is a very simple circuit just to make the case. And of course we can go to the phasor analysis. Again, we want to have it at 50 Hertz. So you see the individual phasors at the elements where you want to see it. I have a little bit a simpler model of a transmission line. I mean simpler to input, but it's basically exactly the same. This is what I want to show you now. This model is a little bit easier if you use it, for example, for power flow calculations. It's easier to set up, but you need to have at least one ground connection somewhere. So in this case I put a grounding arrow on the source at the beginning and also one at the end. So you see I will also put the grounding symbol at the end of the resistance. Also here, the input mask of the transmission line, I input the data. So resistance per meter, then the impedance, again it should be a cable, then I put in 30 kilometers. I want to make a transient simulation of the first 20 to 40 milliseconds. You see this is the first 40 milliseconds. I see how this behaves. So it's the same as before, but just easier to input the data. So I now make my first very simple power flow analysis. You can see I increase or decrease the resistor, the value of the resistor at the end of the line, and you can see how this influences the power flow. Instead of just the resistance as a line termination, I put now another source, and I can see now how I will be able to see how the change of the phase angle of the source will change the power flow of the system. So this is the first mini power flow analysis, let's say. So I change now the phase angle of one of the sources, and you can see how this directly impacts the power flow, and you can see the value of the real power flow across the line. It's the real power flow which is shown on the line. I can go for a phasor evaluation, and you can see here also how the phase angles influence the power flowing across the system. Again, this is a very, very simple system. In reality, you would have to deal with much more complex systems, but it's very easy to assemble such a complex system with this kind of program. It's very responsive, it's very fast. So this is now the example of a little bit larger system, which I have already shown at the beginning. I add now another source. So it's a repetition of what I did before in the much more simpler arrangement. This is a little bit more complex, but now I can really see how the various phase angles of the sources influence the power flow across the whole grid. This one is still a very simple setup. You can see on the lines the arrows and the values of the real power flow. I'm just focusing on the real power flows. You see also the real power at the sources and at the loads. I can also show how I lose, for example, the stability. Here I see a runaway of one of the generators. This should never happen in a real grid, of course, but here you can really learn how this whole thing works. So it's a browser-based circuit simulator. You can go to www.ecsb.ch, and I'm sure that you will see how much you can learn with this fantastic tool.